Hi everyone, it's Mrs. C here with Math Defined. Are you ready to master one-step inequalities? We're solving them today using multiplication and division, graphing the solutions, and even diving into a real-life challenge. Let's get started. First up, we have w divided by 5 is less than or equal to -3. To solve for w, we need to undo the division by 5. How do we do that? By multiplying both sides by 5. The 5's on the left side cancel out, leaving w is less than or equal to. On the right side, -3 times +5 is -15. The solution for w is any value that is less than or equal to -15. Let's graph it. Since -15 is included in the solution for w, we need to place a closed circle on -15. Then we'll draw this arrow shading all values less than -15. It's always a good idea to check the solution. We need to choose a value less than -15, say -20, and substitute it back in place of the w in the original inequality. On the left side, -20 divided by 5 is -4. And -4 is less than -3, so both our solution and our graph are correct. Let's keep the momentum going with another example. Next, we have -16 is greater than y divided by 2. Before we solve for y, let's rewrite y divided by 2 as the fraction y over 2. Now it's clear that to solve for y, we need to multiply both sides by 2. The 2's on the right side cancel out, leaving y is less than. On the left side, 2 times -16 is -32. Let's graph the solution. We need an open circle at -32 since it is not included. If you read the inequality from left to right, it says -32 is greater than y, and many students will mistakenly draw their arrow shading values greater than -32. Let's see what happens when we check our solution. We'll substitute -30 back into the inequality. On the right side, -30 divided by +2 is -15. Is -16 greater than -15? No. Our arrow is shading the wrong values. We need the arrow to shade values less than -32 because y is less than -32. Did you notice that I rewrote the inequality with the variable y on the left side instead of the right? Both of these inequalities say the same thing. Y is less than -32. A helpful tip to remember is when writing an inequality, placing the variable on the left side makes it easier to see which direction to draw the arrow. Just remember to flip the inequality symbol when you flip the variable to the left side. Now let's solve 7x is greater than or equal to -49. Notice the variable is on the left side this time. Having the variable on the left makes it easy to see which direction to draw the arrow on our graph once we solve it. To isolate x, we'll divide both sides by 7. The 7's on the left side cancel out, leaving x is greater than or equal to. On the right, -49 divided by +7 is -7. The solution is x is greater than or equal to -7. Let's graph it. We need a closed circle at -7, and the arrow will shade values greater than -7. Let's check. I'll substitute -2 back into the inequality. +7 times -2 is -14. Is -14 greater than -49? Yes. Let's turn up the challenge with -3h is less than -14. This one has a twist. We'll need to flip the inequality. Let's see why. To solve for h, we need to divide both sides by -3. On the left, the -3's cancel out, leaving h. Since we divided by the same negative number, -3, on both sides, there is a rule that we must follow. When multiplying or dividing each side of an inequality by the same negative number, the inequality sign must be flipped or reversed to keep the inequality true. So after canceling out the negative 3's on the left side, we are left with h is greater than. On the right side, we have negative 14 over negative 3. We can simplify this by dividing negative 3 into negative 14 4 times with 2/3 left over. Remember, dividing a negative by a negative results in a positive value. So the solution is h is greater than positive 4 2/3. Let's graph it. We'll place an open circle at positive 4 2/3 and draw an arrow shading all values greater than 4 2/3. Let's use positive 5 to check our solution. Negative 3 times positive 5 is negative 15. Is negative 15 less than negative 14? Yes. Here's a slightly trickier one. Remember the rules we've learned so far. If you want to try this one on your own, pause the video now. Here we go. To solve for n, we need to divide both sides by negative 2. On the right side, the negative 2's cancel out, leaving n. But remember our rule that dividing an inequality by the same negative number on both sides means that we must also flip the inequality sign. Moving on to the left side, positive 26 divided by negative 2 is negative 13. Before we graph the solution, let's rewrite this inequality so that the variable is on the left side instead of the right. Remember to flip the inequality sign when you flip the variable to the other side. Both of these inequalities say the same thing. N is less than negative 13. We'll place an open circle at negative 13 and then draw an arrow shading values less than negative 13. Let's check it. We'll use negative 15 and substitute it back into the inequality. Negative 2 times negative 15 is positive 30. Is 26 less than 30? Yes, it is. Up next is an inequality with a fraction. Negative 1/3 p is greater than or equal to positive 8. To solve for p, we need to multiply both sides by the reciprocal of negative 1/3, which is negative 3 over 1, or just negative 3. Multiplying by this reciprocal not only cancels out the fraction on the left side, leaving p, but also flips the inequality sign because we are multiplying by the same negative number on both sides. On the right side, positive 8 times negative 3 is negative 24. So the solution is p is less than or equal to negative 24. Let's graph it. We'll place a closed circle on negative 24 and draw an arrow shading values less than negative 24. To check, we'll substitute negative 27 back into the inequality. Negative 1/3 times negative 27 is positive 27/3, which we can simplify to positive 9. Is positive 9 greater than positive 8? Yes, it is. Finally, a real-world problem. You are moving some boxes into a storage container that is 12.5 or 12.5 feet high, and the boxes are 27 inches high. Use an inequality to find the number of boxes that you can stack vertically in the storage container. Since the storage container's height is measured in feet and the box in inches, let's convert the box height from 27 inches to feet to ensure the units match. We can use a fraction ratio to convert 27 inches into feet. Since there are 12 inches in 1 foot, the fraction is 27 over 12. We'll simplify this by dividing 12 into 27 2 times with 3/12 left over, which simplifies to 2 1/4 feet. Converting it into a decimal is 2.25 feet. Now for the inequality. Let's use the variable b to represent each box. We know that the total height of all the stacked boxes has to be less than or equal to 12.5 feet. We also know that each box is 2.25 feet high. So the inequality is 2.25b is less than or equal to 12.5. We'll solve for b by dividing both sides by 2.25. On the left side, the 2.25's cancel out, leaving b is less than or equal to. On the right side, 12.5 divided by 2.25 is 5.5 repeating. So this means that you can vertically stack 1, 2, 3, 4, 5 boxes in the storage container with a little space left over at the top. Remember, the keys to solving an inequality are to isolate the variable, graph the solution, and always check your work to avoid mistakes. You'll want to watch this video next, solving two-step inequalities. See you there! Thanks for watching, and I hope this video helped you out. And until next time, keep math awesome.